Hello, today we're going to go through Lab Section 6.2, dealing with the Babylonian and Mayan systems. So for number one, how does the Babylonian system relate to telling time? Just consider that since we're in base 60, you can look at the first three place values as being hours, minutes, and seconds. For number two, to convert the Babylonian numeral to Hindu Arabic, we note that there's only one place value, so it's additive, meaning we have 3 tens and 4 ones, so we get 34. For the next one, we have 3 place values, so let's draw our boxes. Our 3600s, our 60s, and our ones. And we'll write the value inside of each one. Like in the ones, there's a 10. And in the 60s, there's a 10 and a 1, so 11 altogether. And in the 3600s, or in other words, 60 squared, there's a 2. Just like in the last section, we multiply the values with how much there is in each of them. And we end up getting 10, 660, and 7200. We add these all together and we end up with 7070. For 3a, we want to convert going the other way, 1455 to a Babylonian numeral. So what we really need to do is figure out, well, the 3600 doesn't go into 1455, so realistically we only have 2 place values. We have our 60s and our ones. So I want to know how many 60s go into 1455, and we can kind of cheat with a calculator. We know it gets 24 point something, so it goes in 24 times. 24 times 60, you get 1440 with remainder 15. So we get 24 in the 60s place, and then, well, how many ones go into the 15 remaining? Well, 15. And after that, all we do is convert each to Babylonian numerals. So we have 24, that would be 2 tens and 4 daggers. And then 15 would be 1 10 and 5 daggers. Okay. Same idea for the next one. This time we do have 3600 going into that. So we want to know, we'll have 3 place values this time. Our 60 squareds, 60 to the first, and 60 to the 0. So we want to know how many times does 3600 go into 14,570. Again, just use your calculator. It goes in 4 times. 4 times 3600 is that wonderful number. We subtract that off and we get 170. So there should be a 4 in the 3600's place. Now I want to know how many 60s go into what's left. 170. Well, 2. With the remainder 50. And then finally, just for the sake of completion, how many 1s go into 50? Well, 50. With the remainder 0. And likewise, we write down 4, which must be 4 daggers. 2, which would be 2 daggers. And we just kind of make a space between to indicate that we're in a new place value. And 50 would be 5 10s. Put that last one in there. Okay, and we have our answer. For number 4, how does the one numeral differ from the other? Well, it differs in terms of place values. The first one only has 1 place value. The second one has 2 place values, indicated by a gap. So the first one is just 1 10 and 2 1s, so 12. The next one has a 10 in the 60s, so 600. And then 2 1s. So this would be 602. So certainly, depending on whether we have a space or not, totally changes the numeral entirely. For number 5, we want to add these numerals similar to the way that we did the Egyptian adding, meaning we want to, as best as we can, stay within the Babylonian system, which means carrying if we're over 60. Well, so altogether, we want to circle if we have 6 10s, and we do. So that becomes 1 extra 1 in the next place. And then when we're adding, we're just left with exactly what we have all together. 2 10s, 3 1s in that one place. In the next place, again, we want to look and see, do we have more than 60? No, we don't. So we can just add these up. Five 10s, and then add these all up by just putting them next to each other. If we really want to be clear, that makes it obvious that we only have 2 place values. Okay, finally, for the Mayan numerals, it's the same idea, but now we have unusual place values. They're not really powers of anything. So we have our 1s place, our 20s place and our 360s place. Well, it's the same idea though. I want to just write what these numbers literally are. So we have 3, 0, and 7. Multiply the values with what they're worth, and we end up with 1080, 0, 7. So this number in our system would be 1087. Same idea with this guy to the right. The top place value is the highest. We have 6, 9, 0, and 3. These are all on your formula sheet. And the place values are 7,200s, 360s, 20s, and 1s. So we multiply this all up, we get 43,200, 3,240, 0, and 3. Adding them up, we get 46,443. And then that's our number in the Hindu Arabic system. Finally, we want to go backwards. We have a number in our system, and we would like to write it as a Mayan numeral. So, we want to know, same idea, how many 360s go into 4,233? Well, 11. Again, on your calculator, it's going to be 11 point something, so in other words, it goes in 11 times. And we have 273 as a remainder. But on the side, I want to make note of what these numbers are as we find them out. So that should be an 11 up top. And then moving on, I want to know how many 20s go into what we have left. So it goes in 13 times, and we have 13 left over. And finally, for completion's sake, how many ones go into what we have left? 13. And now on the right, we want to just finish the problem by writing it using the Mayan numerals. So 10 would be 2 bars and 1 dot. 13 would be 2 bars and 3 dots. And same with this guy.